I wouldn't have minded so much. The 1 wouldn't have been that big a deal. For anyone just joining us, we did start section 10.1 notes. I had a little logistical something I had to take care of. And so the students already wrote down this page. And we'll get back to it in just 1 second. Maybe you want to pause and write it down. But we are currently on this page. And I gave the advice for this direction of find the inclination, which we talked about. What word was in there again? Incline. I gave the advice to go from standard form to slope-intercept form. What did you guys get as your equation for A? X minus 2. Good. You got minus 2, not plus 2, right? Good. And then for letter B, what did you guys get? Y equals? Also good. So then I was just asking the students as far as what they got for the slopes of each, because that was one of the things that I asked them to identify. So we have -1, I apologize, +1 and -2/3. Why did I say I don't mind the 1 so much? If I was just mentioning how I don't have a calculator, it's not in my head, I need you guys to have yours out, why wouldn't I mind the 1? It's unit circle. What do you mean it's unit circle? M equals 1. What does that have to do with unit circle? Ah, up here, I told you guys that you should look at the formula, and the formula says set that m equal to tangent of, don't know why it's up in the sky, but that's okay, let's bring it down, tangent of theta. What do you mean unit circle? When does this occur? Okay, when sine and cosine are both rad 2 over 2, which happens where or when? Good. We could say 45, we could say pi over 4. To be honest, in this section, degrees is totally fine. So we could say 45 degrees. Technically, shouldn't we also go in the 3rd quadrant if this was unit circle? Why would tangent also be a +1 in the 3rd quadrant? Sine and cosine are negative, right? And so a negative over a negative would be a +1 as well. However, why am I not having you put that? If you were to go 45 degrees, a 45-degree incline, does that make sense? If you were to go a 45-degree incline, couldn't that also be stated as, what would that be, a 215? No, sorry, 225. As a 225 incline, wouldn't that be the same line? Does that make sense? So if we're just talking about incline, I mean, I guess we could say a 225-degree incline. Kind of awkward, and theoretically your road just got like flipped upside down and turning that way, right? Because if a road had that inclination, shouldn't it technically have gone and inclined that much, and all of a sudden all the cars are upside down? That'd be bad. Hopefully not an earthquake. Anyway, so then here, 45 degrees makes way more sense for an inclination. We're not going to go 3rd quadrant, even though the unit circle might tell us that. But why do I mind -2/3? That's not unit circle, right? What are my different tangent values? Remember the song? 0. For tangent, because it's tangent. Square root of over 1 square root of 3, 0 and undefined, right? Square root of 3 over 3, 1 square root of 3. Well, go team. Anyway, yes, that's why technically, even though I didn't have you write it down, I do have at the very beginning of chapter 10 notes a little like, hey, remember that this was a thing that we could have remembered as far as sine and cosine? Remember sine counts up? Sine counts up. 1, 2, 3. What's cosine do? 3, 2, 1. All over 2. Square root of 3 over 3, 1 square root of 3. But what are we missing? Except for the zeros and 90s. So what's going on at sine? Wait, it's counting up. So where did it start from? And then it's whoosh, and then backwards. Ooh, did I not put a 2? Silly me. And then how do I get tangent from the other 2 rows? Ooh, rows and columns, matrices. Anyway, tangent comes from sine over cosine, which would be 0. Sine over cosine, which would be... Anyway, so I didn't mind 1, but I do mind -2/3. So hopefully when you guys went to solve this, you went ahead and set -2/3 equal to tangent of theta and used your calculator by taking what of both sides? And if you were in degree mode, just to make it easy on my poor little brain and yours as well, what would you end up getting? Give me one more. Okay. -33.690 degrees. Now, inclination, what does that mean about the slope? Is it uphill or downhill? Is it sloped up or sloped down? Exactly. So then we would go ahead and, from our horizontal, go down 33, which is totally good. But is there another way? It does get us to the line, negative 33.690, but is there another way? Let's say we're not trying to be negative today. Is there a way to show this positively? And if you add 180, what might be a better way of talking about inclination? Because most people wouldn't think of going down. They'd think of rotating up. What would that be? 180 plus negative 33.690? Perfect. So up here, we're going to call theta the angle, if I can get it. Oh my goodness, it was working so well. The angle of inclination. Does that make sense? How inclined a line is? So theta is going to be the angle of inclination. M, well, that's easy. What's M always been and will always be? Slope. Which, if they give us like standard form, we could go ahead and actually get y equals mx plus b. If they give us something like 2 points, we could always do, what's that old-fashioned formula for slope again? Good, y2 minus y1 over x2 minus x1, change in y's over change in x's. And then if you get into calculus, we could say that slope is also the first derivative of a function at a point. But anyway, that's for tangent lines. Let's go back a page and make sure that we're good on what's going on, but most of it should be pretty much review. Slope, oh hey, this is where I wanted you to write it. Slope, rise over run. Delta, which means what in math? Most STEM classes, change in delta y over delta x, and as you guys already said, y2 minus y1 all over x2 minus x1, which can be seen as the ratio of how to progress from any inclination. You guys already wrote it down and defined it. The positive angle measured, inclination is an angle. The positive angle measured in standard position from the horizontal to the line. Did anybody, maybe you didn't see it because it was too zoomed out, but the pictures down below, did anybody think it was weird that for the horizontal line, theta was equal to 0? Weird to anybody? Oh, maybe it's just me. I might just be overcomplicating it. Now that we've covered vectors, hopefully it wouldn't be weird, but for just a few of you, hold on, just hold with me. 0's down here in your brain, right? Is anybody thinking that way, like me? 0's down here, right? 0, 45, 90. What's going on up there? So some people would try to like draw angles, but if you're thinking about the inclination, well, even if you're up off the ground, still, what's your angle of inclination? Right. So just in case that would confuse some of you, just think vectors in the sense that you can think about this down here. It'd be an equal vector. Or another way of thinking about it is just what's the slope? Theta, the angle of inclination is 0. Because what's the slope of any horizontal line? 0. What's the slope of any vertical line where the inclination would be 90 degrees or pi over 2? What would the slope be, though? The inclination would be 90 degrees. Undefined. Good. Remember, now it's a mu. That's random. Undefined. The slope of any vertical line is always undefined. If you try to ski it, you would be undefined. Anyway, so acute angles. I mean, we're not going to go too crazy, but there's going to be an acute inclination whenever m is what sign? Oh, whenever m is. So acute, the angle will be less than 90. When m, the slope is, what's going to be true of any acute angle with the slope? Not a number.